There are three main things that are interacting all the time when we look at virus survival, virus inactivation or risk assessment, which is water activity, temperature of the process, and the composition, the feed composition. Those three variables interact all the time, and we don't really understand what is the effect of those three variables on virus survival.
Hello, welcome to the Feed Science Podcast. I'm your host, Ron Hollenbeck, and today we're joined by Fernando Sampedro at the University of Minnesota. Welcome, Fernando.
Thank you. Welcome, everybody.
If you would, just give us a little background, history on yourself, what you do, anything you'd like to share.
Sure. I'm originally from Spain, so I did my PhD in food science over there, and then I came to the US 2009. I did postdoctoral research at USDA, working mainly in food safety, and then I landed at Minnesota, University of Minnesota in 2011, and I've been doing a lot of work related to food safety and risk analysis. And lately, in the last 5 years, I've been more involved in feed safety and inactivation of viruses, risk assessment, processing, all that activities. And it was very, very interesting. Working mainly with feed nutritionists, virologists, veterinarians. So it was a great experience to have different disciplines working together in that field.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
So how, if you would, kind of describe what you'd like to share with everyone on the podcast today, and kind of, I guess, take off the discussion, if you would, please.
Yeah, absolutely. Actually, one of the topics that intrigues me a lot, and I've been sharing this concept, when I'm teaching courses or giving a talk, is the difference between hazard and risk. And, so risk assessment is a discipline that, has been for years applied, right, to solve complex issues or trying to give an answer to risk managers like food safety agencies or government agencies, right? But sometimes, just the presence of a virus or a bacteria doesn't mean that the consumer or the animal will get sick. And, sometimes we say, oh yeah, African Swine Fever, right? I mean, just the presence of the virus doesn't mean that the animals or let's say salmonella, right? That the person will get sick, right? There is something that sometimes we forget, and it's the dose or concentration of the hazard in the portion or sample that a person or animal will consume, right? And if we look at viruses like porcine epidemic diarrhea virus, PEDV, right? There have been studies already done on what is the actual oral dose for a pig to get infected. And we're talking about a very small dose, like 50 particles, right, per gram of the feed sample to a pig to get infected, right? But if we talk about African swine fever, for example, we talk about hundreds of thousands particles, right, in a feed sample for a pig to get infected. And that's one part of it, right? The second part of it is most of the detection methods that we're using, like quantitative PCR, they measure the amount of virus, but we don't know if the virus is infective or not. So again, just the presence of the virus, just saying that the virus is present doesn't mean that the animal or or let's say salmonella, someone will get infected. So we need to know what is the infective concentration of the virus, of the bacteria in that sample. So that's kind of the difference. And then we can apply those response models, right? We can apply the risk assessment methodology to know, okay, what is the likelihood for an animal to get infected based on the concentration of that virus. And if we look at the feed chain, we can also say, okay, what could be the concentration in a raw material, in an ingredient? What are the different steps that the feed will go through, right? Like thermal process. Sometimes we do a storage, right? And that will count in terms of how the virus will behave through that feed chain processes. And, that's how we use risk assessment. And that's why we use risk assessment, right? Because we want to make sure that we go beyond the presence of a virus, of a bacteria, and look really at what is the final risk of an animal or a person to get infected with that.
When you talk about the particle concentration in a sample, let's say soybean meal.
Mm-hmm.
And we'll just say that it's in a standard grow finish diet. Let's say it's 12% of the diet. So, I mean, you have a concentration of the virus in the soybean meal. It gets mixed into a complete feed. It gets diluted. Is it known how many particles the animal has to consume before they become infected? And this is maybe a stupid question, but I struggle when we talk about concentration of particles in a sample. When you make feed out of it, it gets diluted. So how does that impact the infection of the animals?
No, that's a great question. So that's part of the risk assessment, right? Modeling that you do. So actually, you could start with the soybeans, before processing, and simulate what could be the potential concentration, let's say, because there is fecal material, contamination for a wild boar, for example, right, in the field. So you could say, okay, this is the amount that we could find in a fecal material. How much gets into the soybeans, right? What is the process of manufacturing soybean meal, correct? So you are trying to model, right, how much concentration of the virus is surviving the process. And then you have the soybean meal, right, that it will be mixed with other ingredients to manufacture a complete feed, right? And you're completely right. Yeah, there is dilution factor in it. And then you need to take into account what are the species. Different species will have different, ratios, right, of different ingredients, right? And ages of the animal, right? Piglets versus finish, you have these different variables that you can put into the model to predict at the end of the day, right? What is the risk? How many animals could potentially get infected based on an initial concentration, right? You can, that's the nice thing about the risk assessment model. You can connect all those modules to predict, at the end, how many animals could get infected.
Yeah, I mean, as you can tell by some of these questions, I'm not real well versed in what you're explaining. My background's on the operations side and feed. So, we've always talked about, let's say in the pelleting process, we want a minimum of 180 degrees at the conditioner to hopefully kill anything that may be present in the feed ingredients. And I've set in on a couple of presentations from university folks that have done all of this research and analysis. And like when you start talking about African swine fever and how my understanding anyway is how difficult it is to kill. it's honestly it's quite scary from a feed mill perspective, because with current technologies and the way feed mills are currently run, it doesn't appear from a procedure or processing standpoint we'd be able to kill that virus at the feed mill if it were present in any of the ingredients. I mean, what are your thoughts and experiences on that? Because to me, it's really scary. If that virus hits this country, it's going to change our world.
Yeah, and African swine fever, it's I will say it's an special virus in that sense, and how stable it is, how thermally stable it is. The other thing that I want to bring also here is some concepts. I think some concepts that we're using in food safety can be applied to feed safety. For example, if you want to validate, let's say, pelleting, right? There is already a methodology that, for example, the Food Safety Modernization Act, right, FISMA, from FDA, is telling all the food companies you need to validate your preventive controls, right? Processing controls, right? So there is already a methodology, or using a surrogate, or getting the time, temperature, conditions of the product, against the hazard that you want to inactivate, and make sure that you're reaching, let's say, 3, 4, 5 log reductions, right? That's a concept that most of the food companies are using. I think it will be very interesting to apply the same concept to, like, let's say, pelleting, right, that you were mentioning, right, or any conditioning that you are doing. And the key here is to measure the actual product temperature. So I've seen some of the processing conditions that you measure the air temperature, but you don't measure the product temperature, and that's key, right? You need to know what is the product temperature in order to validate your process, right? The problem with African swine fever is we don't have a clear surrogate, right? I mean, like a virus that is completely safe, that we can put in a feed sample, run through pelleting in a pilot plant, right? And establish the conditions, right? And measure the concentration at the beginning, at the end, doing the replicates, right? And doing the correct methodology to, understand if the virus is being inactivated, right? We are doing some work at the University of Minnesota to trying to find a surrogate for African swine fever. But that's not easy, because it needs to behave the same as the actual virus, right? So Dr. Declan, he's a virologist at the University of Minnesota. He found algae virus that behaves very similarly to African swine fever. And we are publishing that research, right, to show that, yes, we have found a surrogate, and we can start validating some of the processes, right, in the feed manufacturing operations, as you said, to make sure that the conditions may or may not inactivate African swine fever, right? But we can use other viruses like PDV or other viruses, and we can do the same methodology of validation that we have used in food safety.
Have you done much work on, how different viruses, if they're in an ingredient, then that ingredient dust is going to end up in the mill. How that virus will get tracked through the mill and continue, increase spread, I guess, of that pathogen throughout the mill, as well as into future feed productions.
I haven't per se, but I know that other universities in the US, like Kansas State, they have done a lot of work on cross-contamination in feed mills, and how virus can, be persistent in some surfaces, and then how the cross-contamination can be. There's a lot of work done in PDV, for example, on that. The beauty about risk assessment, if I can take that data, put it into a model, and model the transfer coefficients, right? That's called, transfer coefficient. So we can model, like a regular a feed mill operation, and what will be the changes in concentration, throughout the day or throughout a week right, based on those transfer coefficients. So the beauty about risk assessment, if we can take data from different articles, different research papers, and putting everything into a model to simulate what the behavior of a virus will be. The other thing that I want to bring up also to the conversation is the concept of water activity. So water activity, it's a concept that we have used in food safety for quite a long time to explain the behavior of bacteria at foodborne viruses in samples. And most of the studies that have been done in the US at least, right, with viruses to explain the behavior of a virus in a feed ingredient, the problem is you add liquid into a feed sample. So the moment that you add liquid in a feed sample, you completely change the moisture and water activity of that sample. So when you are trying to simulate what is the virus behavior, right, in that sample, that completely changes, right, the conditions, because it's not a dry sample anymore. You have added water, and we know that water will increase virus survival, right? So I will say that most of the inoculation studies that you can find in published studies, the biggest limitation is that we're completely changing the water activity conditions of the sample. So we don't know really what will be the behavior if we could do like what is called dry heat, right? Like heating a sample, right, with the virus in dry conditions without altering the water activity. And water activity is a concept that we need to research more. We need to explain better how water activity will affect virus, swine or animal viruses in feed matrices.
Well, that's interesting because, I mean, as we get back to the pelleting process, I mean, we're adding steam. We need to add moisture to that feed in the conditioner so we can press it through the die. And I mean, our goal is, I guess, at the cooler to take the water that was added in the conditioning process, take that water out. But, I would say in most, most large scale feed mills, I don't know how much that's really tested to confirm that, because just from a pure cost perspective, you don't want to take more moisture out than you put in, because then you're essentially losing money, because what you scaled up for that ton of feed is now less than that. But yeah, I don't know that there's a lot of study that's been done on verifying are our coolers, or the way we're operating the coolers, doing what we think needs to be done. But if I understand what you just said, from a bacteria or pathogen, I guess, perspective, we'd probably be better off if we dried it beyond what it initially was. I mean, that's certainly a new concept in how we operate feed mills today, and what we may need to be looking at changing for tomorrow.
And that's a great point, because we could think about a critical control point based on moisture. Mm-hmm. Saying you need to reach this minimum moisture, in order to assure that whatever virus or bacteria is surviving the process won't, it will die off because of the low in moisture content of the sample. And, so we always focus on temperature, and we know that temperature, of course, that's a traditional method to kill the pathogen. But what about moisture? We never thought about moisture content, and moisture content has a huge impact as well on the survival of viruses or bacteria in a feed sample.
Well, and in feed mills, I'll speak for myself anyway. I liked liquid ingredients because they can be pumping into the mixer, and you're not having to scale up those, say, amino acids in the microscale. So you may be adding, liquid lysine or liquid methionine, adding choline in certain diets. Well, I mean, that's adding to that moisture content in the feed, and back to the same pelleting concept. We're starting out at a higher moisture because a percentage of those ingredients is water. We're potentially making this issue worse.
Yeah, could be, but that's the beauty about validation and modeling and inoculation studies with surrogates, that you can mimic the conditions of pelleting in a pilot plant. You can change different moisture contents, right? Adding different ingredients, liquid, dry, and trying to mimic the behavior of those viruses at the end. The other thing that I want to bring also is the storage. Storage has an effect on viruses survival. So we know, for example, we did a project with porcine plasma producers, and it's clear, the research is clear on if we extend the storage for, let's say, a couple of weeks at room temperature, that will also inactivate the virus, will make the virus not infectious, right, with time. And that's a concept that also, we need to explore more. Or let's say transoceanic shipments, there's been some work done also on that. Yeah, viruses will be inactivated, with time in a dry environment, right? It also depends on the temperature. If we are in a freezing temperatures, the reduction will be very small. But if we're at room temperature, viruses won't survive in that dry environment of a feed with time. So that standard storage is also a concept that, also important. It's another additional step or additional hurdle for the virus.
So are you seeing ingredient manufacturers changing their processes, or from a storage standpoint, quarantining products for a longer period of time than they used to? How is that changing the ingredient suppliers world?
Yeah, I've seen like feed manufacturers like extending the storage before using the ingredients when they are coming overseas. One of the key aspects is to fine tuning what is the temperature, right temperature to storage the ingredients, right? Because if you increase too much the temperature and you have some humidity in, let's say, a grain-based ingredient, you may also affect quality or safety, right, of the ingredient. You may increase mold growth, and that could be mycotoxins, right? Or potentially salmonella could grow in the product, right? So fine-tuning the right temperature, not going too really high, but like allowing enough temperature for the virus to be inactivated with time. That's part of the research also that we need to fine tune. But I've seen feed manufacturers like having warehouses where they keep the ingredient for more time at room temperature as an extra layer of safety.
Are you involved, or have you I guess heard of any additional research occurring for if we make the assumption that at the feed mill level we won't be able to fully inoculate the virus with our current processing capabilities, are there more research and investigation being done on potential chemical treatments? I know there's a few out on the market today that I think certainly have success in inoculating some of those viruses and bacteria. Is there additional research being conducted that to improve or increase the number of say chemical treatments that will be available in the marketplace?
Yeah, we have done some research at the University of Minnesota, like evaluating some of the chemicals and what is the effect of some like swine viruses. I will, and they work, but I will say that's an extra cost, right? We're adding cost to the manufacturing process, right? I will say that the decision to add a chemical should be risk-based. We know that there are ingredients that, because of the process, because of the conditions that they are harvested, or because of the condition of the raw materials, they are low risk ingredients. So, and the process, the nature of the ingredients will take care of any potential contamination, right? So I will say that, in order to make the decision to use a chemical, right, as additional protection layer, should be for the high risk ingredients that come from overseas, that may be contaminated with fecal material. We don't have any any thermal process to potentially kill the virus, has a short shelf life, right? A short storage. Maybe the moisture content is high. So we start to see what are the risk factors that will affect us as manufacturers, right? The decision to say, okay, we really need an extra layer of protection, which could be extended storage, could be adding a chemical, but that won't be, I won't recommend that to any ingredient, right? I mean, it has to be risk-based, and we need to make the decision based on those risk factors.
Okay, good. What other research and things have you conducted that would be of value to discuss with the audience today?
I think we have touched a lot of different concepts and a lot of different research aspects. I will say there are three main things that are interacting all the time when we look at virus survival, virus inactivation or risk assessment, which is water activity, temperature of the process, and the composition, the feed composition. Those three variables interact all the time, and we don't really understand what is the effect of those three variables on virus survival, right? We may have a low water activity, high temperature, low temperature, high water activity, and we may have those two control, but then when we inoculate in different feed ingredients, we see that there are some ingredients where the virus survives longer and other ingredients where the virus survives much shorter. And we don't know if it's the fat, if it's the protein content, if it's like an antioxidant compound that the ingredient has that affects virus survival. We don't know that yet. But we see huge differences, right? When we inoculate viruses in different feed ingredients. And again, when we keep water activity and temperature stable, constant, we still see that the feed composition has an effect on virus survival. So we need more research on that to truly understand what's happening with the feed composition and virus survival.
And when you say more research is needed, how do you go about setting up that research? Who do you work with? Just in general, how would that be structured?
Right. So I think at universities we have the beauty to able to form multidisciplinary research teams. Some are food scientists, right? Food safety, risk assessment, and I collaborate a lot with feed nutritionists, right? Feed manufacturers, virologists, veterinarians, which bring different expertise to the table, right? And we need all of those dimensions to really establish a strong research group. We need lab capabilities. We need a pilot plant. At universities, we usually have pilot plants where we can, do inoculation studies, right, with surrogates. So all of that will be needed, in order to understand that. How you design the research, I will say you start with a basic ingredient, and you add different concentration of protein, different concentration of fat. So you start to do one variable at a time, and measure what is the effect of increasing the fat concentration or the protein concentration or other key components of the feed into virus survival. And you do enough replicates to get the results that you want, and then you establish inactivation kinetics. And with that, you can say, okay, what is the net effect of protein? What is the net effect of fat? What is the net effect of, minerals, vitamins that may have antioxidant potential and affect virus survival? So you do one step by step, and evaluating one variable at a time. That's how I envision conducting that type of research.
Yeah, my mind just, I went to Kansas State and we did some research trials on feed in the pilot mill when I was there, and I understand how that works in a very small, controlled, low throughput, certainly able to clean everything. I mean, have everything just the way you want it. But when you get out into high production plants that, I mean, you've got to put out 2,500 tons a day just to keep the animals fed. The environment is completely different than a research environment, and how that how what you achieve at the research level, how does that get distorted, so to speak, when it gets into a real world high capacity production environment?
Right. So I will say research will give you the critical parameters. What is the moisture content that you should achieve at the end of the process? What is the temperature that you should achieve, right? So those are the two critical. What is the feed composition, if it can be altered in some way to reduce the viability of a virus, right? What are the highest risk ingredients? Research can tell you, okay, in this type of ingredients, you need to add an extra layer of safety. But these ingredients, you are good, it's safe at the way you're producing the ingredient, right? And that's how we partner with feed manufacturers. We ask, is that feasible? Is that economically feasible to reach that moisture content? As you were saying, right? I mean, water, it's money at the end of the day, right? You don't want to take out more water that you had initially. Is that feasible to reach that moisture content, right? Is that feasible to reach that pH, for example, or that temperature? Or how we can measure the temperature of the product, as I was telling you, right? Because that's the key parameter to validate a process, not the air temperature, but actual the product temperature. Can we put like a thermometer or something, a probe, right, into the product to measure that? So research will tell you critical parameters, but then the feed manufacturers will tell you if that's economically feasible or not, how low they can go, right, in their processes, right? So that's kind of the good and fluently conversation that we need to have with feed manufacturers, from research, pilot plant, into a large scale production.
Yeah, I mean, we've talked a fair amount about pelleting, but there are an awful lot of feed mills in this country who do not have pelleting capabilities. Do you, at the university level, work directly with equipment manufacturers to develop, whether it's air heat treatment or whatever for mash feed mills who do not have the capability for steam processing of the feed?
That's a good question. We haven't worked directly with equipment manufacturers. I remember at some point reaching out to some manufacturers to see if they could lease different equipment that we needed for our research project, but I wasn't directly involved. But that's a dimension that we need also to take into account, right? And it's like in food safety, the hygienic design and how do you design the equipment. This is kind of a similar concept, right? how you design the equipment to make sure, like, achieve the conditions that are critical for feed safety. And that's a conversation that we need to have as well, right? Not only with feed manufacturers, but also with equipment manufacturers. Absolutely. Absolutely.
Because I would venture to say there are way more feed mills in operation today who don't have a boiler, don't have any kind of steam heat treatment available. We tend to think about, certainly the large integrators who who believe in pelleting and the effects and the growth improvement for heat processing ingredients. They'll typically have the pelleting systems, and those are a lot of the very high capacity feed mills that are out there today, at least in the United States. So it's I've worked with some of these companies and talked about how do we improve any type of pathogen spread. How do we improve the pathogen control without without the ability for any heat treatment? And I can definitely see where there is a need, and as more more difficult to kill pathogens, continue to arrive or mutate or whatever they do. That's going to be something we're going to have to address as an industry, because as you said earlier, you don't believe chemical treatment is certainly not maybe the first line of defense. It may be required, but in a feed plant that does not have any heat treatment capabilities, right now that's pretty much the only option there is that I'm aware of. So I think there's certainly a need for continued work with with equipment manufacturers to provide some alternative options for pathogen control in the future.
Absolutely. And again, everything needs to be risk-based. Maybe, it depends of the ingredient that you are manufacturing. Not everything needs to go through like thermal treatment. It has to go through a risk assessment and see if it's needed and what other measures you have. You have a storage as well, you have chemicals, as you mentioned, or, the way you're manufacturing or the nature of the ingredient, you are taking care that the ingredient is safe. You don't need to add any extra layer of safety. So everything needs to be risk-based for that decision to be made.
It's time for our famous three. Eastman serves veterinarians and nutritionists in agrochemical and animal health industries by helping them select, evaluate, and implement innovative nutritional programs. Eastman works with your team to customize your gut health approach in feed and water. Eastman's approach addresses nutritional and bacterial challenges and finds new ingredient preservation and hygiene solutions. Explore ways to accelerate and innovate your programs. Contact the animal nutrition team at eastman.com.
Is there anything else you would like to discuss or share before we begin to wrap up this podcast for today?
I think I'm good. I think I share all the concepts that I had in mind to share with the audience.
Okay, yeah. Good. Well, there's a few questions we always like to end these podcasts with. So, can you share what your favorite feed science or nutrition related resource would be? This kind of your go-to for information?
I don't have a specific resource, but I will say the topic of virus, like virus behavior, virology, like animal viruses and how they behave. I think that will be a topic that companies should start looking at, and there is some reviews that have been published on the behavior of different animal viruses, on temperature, a moisture content, pH. So that should be something that feed manufacturers, they should start getting access to and reading, because understanding the behavior of viruses will make companies to understand why we need, to change anything in my process to kill that specific virus. So yeah, the field of viruses and how viruses behave, it's fascinating, and it's a topic that we should get into that.
Well, and along those lines, I think in I would say your larger integrated systems, there is more discussion about viruses and transmission and how do we limit that transition and spread, whether it is within the feed mill or from site to site for animal production. But as you look at a lot of the smaller feed companies as an example, I agree. I don't think that those discussions happen as frequently as they should, and I don't know if that is an issue of it's probably not an issue of not understanding it as a concern. It may be more of an issue of not having that person on staff who understands it, can articulate it, and help train the feed mill and feed drivers and everybody on what they can do to minimize the spread and help with virus and pathogen control. How do you have any thoughts on how those smaller feed companies who may not have that expertise on staff, to how they could access that expertise to help with their training of their staff?
I will say that a couple of ways, right? I mean, I always recommend go at least to a conference each year to get updated in the latest research, equipment, guidance, right? So if I will say I don't have any quality control personnel or I'm lacking, I will say go to those conferences at least once per year, make the investment, to get updated on the latest research, manufacturing equipment, that's totally worth it. And probably, networking, in those conferences, you meet a lot of different people. And there are a lot of different consultants and consultancy companies. Then actually their job is helping those small companies with the latest research and giving them a very specific practical, right, guidance on how things that need to be changed to make sure that the production is safe. So two things, right? Go to at least a national conference per year, and then reach out to consultancy companies if you need help, or universities.
Sure. Okay, good. Next question. What would be your favorite resource for information that may be outside of feed or outside of agriculture?
Yeah, I've been thinking about that, and actually I love the soft skills area. We teach a lot at university how to have a communication skills, right? And some of the leadership skills and working with others and working across cultures, right? In this world today, I think soft skills are not taught enough, I think, at universities. We focus a lot on the technical skills, and probably you will agree with me that during your work life, soft skills are much more important than what your technical skills. how you work with others, how you're able to communicate complex, concepts as we're trying to communicate today, right? Complex issues, right? So most of the people can understand. So there was one book that someone recommended that changed how I saw myself and how I saw others. It's called Strengths Finder. And it's a book that tells you to focus on what are your strengths and not your weaknesses. And at the end of the book, you have like a test that you can do, and it finds your top 5 strengths. And the philosophy of the book, it's like, okay, your job, you should apply your strengths into your job. So everybody has strengths. Your job should be aligned to your strengths. So if you are good at communicating, do more courses on communication. Be exceptional, in communication, and not focus on your weaknesses, because you will always be bad on let's say statistics, right, or mathematics. Don't do that. Focus on your strengths, and that will make you happier in the job that you are trying to apply for. So yeah, that will be my recommendation.
And that's very good advice, but I would say it's easier said than done. I know from my perspective, I tend to focus on my weaknesses and how do you improve them, which I agree it's probably not the right way to approach it, but that's just the way I'm wired. That's where I naturally go. How do you fix what's wrong? So the last question, in your opinion, what separates people in animal nutrition or feed science arenas for who's more successful than others? What attributes or what do you think would helps define people who are more successful?
Yeah, I will go back to a concept that I was sharing before. Actually, 2 things. One is collaborating with other disciplines. We try to be our world in just one dimension, right? Like feed manufacturing, feed science, feed safety. And, there's other fields, other disciplines that can help us a lot. Nutritionists, veterinarians, food scientists, virologists, right? So I think the successful companies or the successful projects is where you bring those disciplines together and working really, truly together, right? That will be one thing. Second thing, I think we can learn. So in the feed science field, we can learn a lot from the food science field, right? I mean, food safety has been for, like 50 years now, maybe. And the level of success in achieving food safety standards, I think we can learn, the feed manufacturers and feed science can learn a lot from food safety. And look at, for example, the concept of water activity, right? That has been very well studied in food safety and bacteria. So I will say the second thing will be try to bring food safety concepts into the feed science world and try to learn from that.
Yep, that makes good sense. Well, Fernando, thank you for your time today. Thank you for your insights. It's been very informational for me, that's for sure.
Absolutely. Thank you for having me, and I hope that it was a good information to share.
Yep. Great. Well, this will conclude our Feed Science podcast for today. Thank you again, Fernando, and thank you for listening.